Hey there. So today we're going to be answering the following question. Two buses depart Hypotenuse Station at the same time. Bus A travels due east at a constant rate of 48 miles per hour, and bus B travels due north at a constant rate of 36 miles per hour. How far apart are the two buses 20 minutes later? Okay, so the first thing you do with any mathematical problem is you draw a picture. So let's draw that. So since we're going north and east, let's draw it here. And so this is going to be our hypotenuse station. So bus A travels due east at a constant rate of 48 miles per hour. So the bus is going to be going this way at 48 miles per hour. And bus B travels due north at a constant rate of 36 miles per hour. Okay. So after 20 minutes, after 20 minutes, we're going to get the following triangle. Remember, these are at right angles here. So we're gonna have a value of A, a value of B, and a value of C. A is going to be the distance that's, let's put some things here. So this one's bus A, and this one's bus B. So bus A is going to be traveling east 48 miles per hour, and that's going to be how, B is going to be how far bus A traveled after so much time. Actually, you know what? Let's make these a little bit simpler. So we're talking with apples with apples. Let's put A down here and B up here. So when we talk about bus A, that represents the A side of the triangle. And when we talk about B, it's going to represent bus B, it's going to represent the B side of the triangle. Okay, so we got that. So we need to figure that out. And so distance. So the formula for that, distance is equal to the speed at which something is going times how long it's going for. Okay, so let's go with let's go with A first. So let's go with distance for A, and let's make that red, and we'll go with blue over here eventually. Okay, distance A. So it's the speed that A is going at, and that's going to be 48 miles per hour times the time, and the time for this is 20 minutes. Okay, so we want to get that in terms of a distance. So let's see if we can get in terms of miles. Now, we can't really, right here it doesn't look quite right, because if we did the multiplication, then our units would be miles times minute over hour, which doesn't make sense. So we need to convert the speed in terms of miles per minutes. So we can do that by doing a little bit of dimensional analysis. So we can do miles per hour times, well, if we want to cancel out the hours, we put the hour on top. So 1 hour is equal to 60 minutes, and throw back in the 20 minutes there. And here, so we have the hours cancel out, and we have the minutes canceling out. So that's going to be equal to 48 times 20 over 60, and the zeros will cancel, and so we will be left with 48 times, well, the 2's, you can divide top and bottom by 2 to get a 3 on the bottom. So to get that, and that will equal 16. So 16 miles. So we have 16. So A is going to be equal to 16. And for the distance for B, well, 36 miles per hour And we have to do the same conversion, so I'll just throw that in here. And same distance. Okay. And remember that 20 over 60 is the same as 1/3. So we're going to have, and remember, the units cancel. So I have 36 over 3 miles, which will give us 12 miles. So it's 12. So, and just for some color, let's C be yellow. Okay, so now we want to solve for C. So solving for C, well, so we can put C is equal to, well, C squared is equal to, so it'll be A squared plus B squared. And so C is going to be equal to the square root of A squared, which is going to be 16 squared, plus 12 squared. And so keep going with that. So 16 squared is equal to, 16 squared is equal to 256, and 12 squared is 144. So together, that's going to be the square root of 400, which is equal to 20. So after 20 minutes, the two buses will be 20 miles apart.